Anyway, all right, let's go ahead and talk about the results for the first part of the lab, which was looking at the quadrant method. So let's see. Jeremy, what was the habitat area that you calculated? We're on table 1 now in the back. So you guys are real detailed. If we had just kind of rounded the percentages up, you should have gotten a value in the ballpark of 352. I'm just doing this for everybody else's sake because most people probably got a number around that. Now the quadrant area, the quadrant or the little cover slip that we used as a quadrant was 2 centimeters by 2 centimeters. So the area for that had to be what? 4. Okay. Now the number of quadrants in the habitat should be 88. Okay, so that's 88. Now to get the estimated population, here's what you would do. You would take your average, whatever this value is up here, and let's take, Tony, what was your average? So you had an average of 5.9. We would take that and multiply it by 88. So let's go ahead and do that. What is 5.5, or 5.9 rather, times 88, gives you an estimated population of 519.2. Which, yeah, you can look, it's way off. Tony, you're so silly. To 298, okay? Now, let's go ahead and calculate the percent error for that. We're going to get a pretty high value for this. Percent error is going to be equal to your estimated value. In this case, we'll just round to 519 minus the actual value you got, 298. And you want to take the absolute value of that. What is absolute value again? Yeah, it'll end up being a positive number. Then we divide that by the actual, which was 298 again, and multiply the whole thing by 100. So this gives us what? So go ahead and make that calculation. 519 minus 298, absolute value, divided by 298 times 100. So 74.2%. That is a very large percent error, okay? Now, when we are taking this into when we're applying this to our hypothesis, whether or not it's supported or not, take a look over here. A 0% error would mean that the estimated and the actual population are the same. Oh, plus or minus 5%, if it's within 5%, then they're close. Greater than 5, they're not close. Or you could almost say that they're different. So for the purposes of the quadrant method, most of you guys, if you predicted that they would indeed be close, then that is not supported. Because they are not close. Now, let's talk about reasons for this. The main reason that this happened is what we call sampling bias. Sampling bias, anybody have an idea what that might mean? Kat? Yeah, what happened was that you guys were throwing that quadrant to areas where there were more crabs. Maybe it was just kind of a psychological bias. Maybe you weren't doing it on, or a subconscious bias. You weren't doing it on purpose, but you just kind of aimed towards them. So in real life, if we were to do this with a real crab population, we would have to find a way to randomize the sampling quadrants so that there would be no bias, and we would get a more accurate result. Now, part two was looking at the mark and recapture process. So Let's see here. Mark Ragland, what was the average percent tag that you guys got? So 11, you said 9? Okay, 11.9%. Okay, now to figure out the estimated population, the population estimate is equal to the original number that you tagged. How many did you guys originally tag? 35? Oh, 75. 75 divided by 11.9 times 100. And this will give you your estimated population. So 75 divided by 11.9 times 100 gives us 630.3. And what was your actual population? 937. Now right there you can see we're still pretty off, but we're a lot closer than the other method. Let's do the percent error. Absolute value of 630 minus 937 divided by 937 times 100. And what do we get? So let's calculate that. Gives you an absolute value of 32.8%. Or excuse me, a percent error of 32.8. Okay, now assuming that you had predicted that it would be close, is your hypothesis supported? No. So this is not supported. Again, because it's not close. Now the reasons for this is that the sample size is too small. If we were really doing this as a real project, in fact, I had a friend that lives in the Tampa area that was gonna, I think he was working on his dissertation and it was measuring fish populations in that area. He spent an entire year and a half collecting data. So he was out in the field all the time collecting fish, tagging them, releasing them, catching them again. So he was doing this, and again, because he wanted a large sample size, because the larger the sample size, the more accurate your measurements will be. Okay, discussion questions. Number one, based on your observations, how accurate were your estimates? Not too accurate. But again, the reasons for this are in parentheses there. Okay, there was sampling bias, and there was also the sample size was too small. And then secondly, which method showed greater accuracy? I mean, neither of them were very accurate, but which one had a lower percent error? Yes, good. So this is the mark and recapture. And again, we can just point to the lower percent error as the reason for that. All right, good. Let me stop that.